In this video, we are going to be focusing on combustion reactions. This is part of our learning objective for describing oxidation reduction reactions. So what is combustion? Combustions are examples of redox reactions with oxygen gas as a reactant. Combustion reactions release a lot of energy, and it's essentially used for internal combustion engines and other fuel and whenever you need heat. So internal combustion engines in cars use the combustion of various hydrocarbons to release gas and a lot of energy, and it's awesome. So whenever you react things with oxygen, it's like tacking on oxygen to everything. So anything containing carbon will form CO2. Anything with hydrogen will form H2O, and that's sulfur, and so that's going to form SO2. And then nitrogen would form NO2. So you can see that we're just pretty much bonding O2 to pretty much anything. You can also combust metals, and if you combust metals, they will form the oxide depending on whatever common ion charge is available for the metal, or you'd make a variety of oxides. So for example, in that internal combustion engine, you have gasoline, which is octane. And so this is the balanced chemical reaction here for the combustion of octane. Now, that brings us to a very important point. Since all of these contain only carbon and hydrogen, what are the products? This is propane, which contains only carbon and hydrogen. This is octane, which contains only carbon and hydrogen. This is wood. Wood is primarily cellulose, and that is primarily made out of carbon and hydrogen and also some oxygen. And this is paper, which is made out of wood, and so that's also made out of carbon, hydrogen, and oxygen. So when we burn any of these things, the only things that are formed are carbon dioxide and water. So no matter what you're burning, whether it's propane, octane, wood, paper, or other things made out of carbon and hydrogen, your products are carbon dioxide and water. So let's write a balanced chemical equation for the combustion of liquid ethanol. Go ahead and pause the video and try to work out this balanced chemical equation on your own. Unpause the video when you are ready to continue. Alright, the first thing we need to do is determine the chemical formula of ethanol. In this line structure, there is a carbon here and a carbon here. That tells us that we have two carbons. This carbon has two lines coming out of it, and so it's going to need two additional hydrogens in order to have 4 total bonds. This carbon is going to need to have 3 hydrogens in order to have 4 total bonds. So that's 1, 2, 3, 4, 5, 6 hydrogens. So we have 2 carbons, 6 hydrogens, and 1 oxygen in this molecule. We know that combustion reactions always react with O2 from the air. Ethanol is a liquid, and that's going to form carbon dioxide and water. Because all combustion reactions for carbon, hydrogen, and even oxygen-containing things form carbon dioxide and water when they burn. And so now that we got our skeleton outline of our chemical equation, put states of matter on things, water is usually hot enough to be a gas at that point, we can start to balance. I will need 2 carbons. I'm going to need 3 of those. And that's going to give me an odd number of oxygens on this side, because 3 times that is going to be an odd number. I'm forced to have, let's see, that's going to give me, maybe I don't need to multiply by 2. Let's find out. So, how many oxygens do I have? I have 4 oxygens here, and I have 3 oxygens here for a total of 7. I have 1 oxygen here, and so that means that this would need to be a 6. And so Now I can make that a 3 so that I have 1 plus 6, which is 7. So now I am balanced. It's important to remember that oxygen over here because that could really mess up your coefficient if you forgot about that oxygen as part of the other reactant. Here's another practice problem for you. This one says, in the combustion of butane, what element is oxidized? Go ahead and pause the video and try to work this out on your own. Unpause the video when you would like to check your work. Okay, so let's go ahead and write out an equation for the combustion of butane so that we can check out our oxidation states. Butane has 4 carbons because it goes meth, eth, prop, bute. And then hydrogen, I would have 2n plus 2, so that's 8 plus 2 is 10 hydrogens. So that's C4H10 reacting with O2 to form CO2 and H2O. I don't really need to balance the whole equation in order to answer this question, because this question is not asking about the equation, it's just asking about oxidation. So I really only need to see what's changing. I can see right away that this oxygen here is a 0 oxidation state, and then in either of these, it's a -2. And so oxygen is reduced. But the question is what's being oxidized. The hydrogen has to be a +1 in both those compounds, so that's not it. And so my carbon has to be what's oxidized. So in the combustion reactions, carbon is oxidized, oxygen is reduced. Because we have to remember that oxygen here is always a 0, and then in carbon dioxide and water, it's always a -2. So oxygen's always being reduced, hydrogen's always going to be a +1, it's carbon that's going to be oxidized.